quality.
Yep. It looks very good.
Can you see it?
Yep.
Okay, cool. All right, so I'm gonna boot the solution.
Mm-hmm.
I also hate Visual Studio, and I haven't like set up my hotkeys and stuff.
You can change it to be the same as VS Code.
I know, I just haven't done it. I've just been lazy. All right. Anyway, so yeah, this is like the thing where, I mean, this basically will tell you almost every file that's like relevant to the fork. You just type in Slippi there.
Mm-hmm.
So I guess we'll start on the CXI Slippi.cpp. That's like this is probably the main file that we care about. So effectively what ends up happening is there's like the assembly codes that are injected into the game via gecko codes or whatever. And during certain parts of the game, they'll like either write out some data or request data or whatever. Either way, it always is initiated. Any type of communication is always initiated with a write from the game. But so the game is either just like requesting that Dolphin do something, or it's requesting for Dolphin to return it some data. And I think nowadays everything is done as DMA writes. Do you know what that means? You know what DMA is?
I do not.
DMA is direct memory access. It's a sort of hardware thing where you configure like for example, for a serial device, it'll read data. You configure it to write to a certain block of memory, and the hardware itself can then write to that memory instead of like having to read 1 byte at a time and then write it to memory from the software side, if that makes sense.
Interesting. Okay.
So
Yeah.
DMA writes are generally a lot more efficient because like things are sort of directly connected to memory.
Mm-hmm.
This isn't strictly relevant on the Dolphin side, but it matters a lot more on the Nintendo side. It's a lot more efficient because we can basically pass blocks of memory, like the whole buffer basically, instead of having to like receive 1 byte at a time, which ends up being really slow because you have to like confirm that you've received it every time.
Yeah.
And yeah, that's really bad. On 1 second. Okay. So yeah, so basically, this function ends up being called anytime the game wants something to happen, and this is the address in memory of the data it's trying to transfer.
Okay.
And then this is the amount, the size of the buffer basically it's transferring. So you'll see what this does is it like creates a U8 pointer, basically an array of bytes
Mm-hmm.
at this address. So it gets the pointer from that address, and then yeah, you got your array there.
Okay.
And then it'll always read the first byte. So the first byte is always the command byte. If we go to like 1 second. So where is this again? I think it's here. Oh no, that's not it. I think it's in the main thing. Yeah. So this spec sort of defines how the SLP files work.
Yep.
Or how they're structured. And it's basically always like command and then like data payload. So command is like something that's happening, and then data payload is the data that's relevant in that. So game start, for example, the command is 0x36, and then it's going to pass in all of this data. So you see at byte 0, you have the command byte, which is 0x36, and then this is all of the data that gets transferred when there's a game start command. From the Dolphin side, it's really simple. For all of the like SLP file stuff, because all it does is like, you'll see it here. So we get 1 byte if it's command receive commands, which I think is what the fuck? Which I think is this 0x35. Let me double check.
That's 50.
Yeah.
Oh, okay.
Yeah.
I'm surprised it automatically translates it when you hover to like.
Oh, instead of writing it as 0x36, yeah.
Yeah.
Um.
In the hex format, but okay.
Yeah. So it's looking for the receive commands byte, because that tells it like the receive commands byte basically sets up everything. It's always the first thing in an SLP file, and it says like, okay, you're gonna get these payloads with these commands, and these are their sizes, so that we can like more easily parse all of the data and make sure we have everything and stuff. So that's
Okay.
always done up front.
So this is the flow you're talking about when you're replaying a file. Is you're saying right now you're taking in an SLP file and then you're.
So actually, no. Right now, I'm talking about when you're writing a file.
Okay.
Let's just start there, because I think that's the easiest, and then
Yeah.
we'll move on to the playback side. But so when you're actually writing a file, like when you're playing on NetPlay,
Yeah.
it's gonna process these commands, which are, it like starts with the receive commands, and then
Okay. So these functions are being called from. Okay, I see. Never mind. Okay, go on.
yeah. So there's an action in the game which ends up calling this
Got it.
function.
Yeah. Okay. I understand now.
Yeah. And uh, you'll see that like all of these are not any of the ones we were just looking at on the SLP parser,
Hmm.
because all of these are for playback. The default though is like everything else. So like all of these commands basically are gonna hit. Oops. Uh, are gonna hit this default, which is just gonna call the write to file function.
Yep.
So all of them just write to this SLP file, right? And that's how the files are created during NetPlay.
Sure.
But during playback, it's a little bit more complicated. So during playback, the game is actually requesting data from Dolphin. So it still initiates with this function, right? So it tells it like, okay, I oh, this is receive game end. So this is the only one that's actually part of the writer, and it just tells it that like after it gets a 0x39, it should close the file, like terminate the file. But all the other ones, so this one, command prepare replay, command read frame, is stock steal, get frame count, is file ready. Those are all for playback. So I think the first one that happens is prepare is file ready, and I can actually just okay. So something that's probably relevant is there's the Slippi SSBM ASM directory, or GitHub repo. So
Mm-hmm.
I'm just gonna grab it right now. I don't have any content changes. I don't know why it actually does this. It like they come up here. I think it's because like some of the metadata changes or something. But there's actually no content changes. Anyway, I'm gonna pull. Looks like Vin added some stuff for tweak boot to CSS code, so the boot process is compatible. Okay. So now
Nice.
that
Wait, it
I've
works with training mode also? That's sick.
what's that?
It will work with training mode also.
Apparently, this is a new thing. I actually haven't asked Vin too much about it, but it should work with
All right.
training mode soon.
Not relevant.
Yeah. So then now that I have this repo, there's a build.bat in here, and you can run this. You need the Gecko dependency, which is a tool I built to basically assemble all of the files. Like it works a little bit like npm, uh, where like you have like these JSON files. Here, I'm just gonna
Uh-huh.
open. This is the ASM repo, which I open in Atom because there's a linter for PowerPC. But yeah, so there's like if I look at netplay.json or whatever, this basically is a configuration file that says like, okay, I want to output this galo1r2.ini file, which is the gecko file for netplay, and there's one for Japanese Melee as well. And then you define like all of these codes and like where the data is. So usually what we do is when we're writing our own code, like for example, we'll go look at the Slippi recording code. There's like, it's like type inject folder. I'm like sort of going a little, I'm going to try to go over this quickly because this isn't strictly related to the Dolphin stuff, but so it's inject folder, and so it basically looks at the recording directory, which is here, and it basically just like assembles all of the files in here into a code, and like the files themselves, they specify where they're supposed to be injected, and it just creates like this injection. So anyway, so what I did is I used build.bat, which uses the gecko tool to build everything, all of the configured outputs. So one of the outputs is, playback. So we can grab the playback codes, which are just like Dolphin gecko configuration files or whatever.
Yep.
And then if I go to here, this is the output of my like when I build in Visual Studio, where it goes.
Yep.
So I can go here and I can just override these files, and I'll just show you the contents of this real quick. So these are all like the compiled codes.
Got it.
Oops. And then when I hit play now, it'll be in playback mode. So I'm just gonna make sure. Okay, so everything, just making sure the codes are correctly enabled, because if I change it to like recording mode, it doesn't have the right codes selected. So yeah, so these are the right codes. So if I hit play now, what it's gonna try to do actually is the default behavior is oh no, this is weird. I don't think it's supposed to do this. I'm supposed to like ignore these. Okay. Anyway, what it does is it goes to the Slippi directory, and it looks at this playback.txt, right? And then it just plays whatever's in here. So this is like the input file that Dolphin uses to figure out what replay to play. So in this case, it's going to play this replay, and there's no like start frame or end frame configured, so it's just going to play the whole thing. And that's what I was trying to do, although it was giving me weirdo errors, which I don't quite understand why. Use panic handlers? I think that's fine. Okay, it's working now. Whatever. Alright, it's really slow, potentially because I'm like streaming and sharing my screen and like doing a bunch of shit.
Yeah, I mean, yeah.
But the point is, what happens is I'm gonna change this to like some file that doesn't exist, right?
Wait, where is this txt file being called from?
Like, where's it being read from, you mean?
Yeah.
So we'll get to that. I wanted to start by just like showing you what happens.
Sure.
Okay. So you get the waiting for game screen, right? And what the waiting for game screen does, and you can do this, I want to show you how you can like use the log to figure out what's happening. So that's the log. That's the Dolphin log, and you can if you go to info and you turn on expansion interface, it should. Okay. So we're getting a bunch of logs, and what's happening is that every frame when you're on the waiting for game screen is actually hitting that function we were looking at before. So this function. So let's just put a breakpoint in here. We're gonna put a break.
So that's what the info log thing does.
Yeah. So the info log is basically logging this.
Okay,
Yeah.
that's someone else wrote that as part of.
Yeah,
Dolphin.
this is the Dolphin logging interface, and the expansion interface was the one I turned on. And then info was the level, right? But basically, I put a breakpoint in here, and you'll see this byte. I'm not in debug mode, so I can't, it's really when you're not in debug mode, it like doesn't. Let's just go to debug mode. It like optimizes a bunch of stuff, so the watchers aren't very good. But when you're in debug mode, it doesn't optimize anything. So, oh god.
What does debug mode do exactly, aside from like? Because there were a couple flags that I couldn't get to trigger, and also loading this is extremely slow.
Yeah, loading debug mode is super slow, but I don't know. I mean, I think like you can configure different build options for debug mode in release, and I think it's actually kind of completely up to you how you decide to do it. But specifically, I think the more important things is that debug mode turns on, like it doesn't optimize any of the code, first of all, so that when you put in a breakpoint, you can actually see everything. Like you saw how I couldn't see the value of byte when I was in release mode. In debug mode, you'll be able to see it. And there's like probably a bunch of other configuration differences, maybe like more logging and stuff.
Yeah, there were like certain menus that you could only see if you flipped some booleans in certain places, but I don't think that was relevant.
Yeah.
Because the log stuff is already useful enough to just see outputs.
I don't know how long this build is gonna be.
Usually takes me like a minute. That looks a lot slower for you.
It takes a really, really long time when it's building everything. I don't think it's building everything right now though. It also like almost freezes my computer at times.
I think 39 is when it stops, or 38, so you're pretty close.
But anyway, basically what's happening is every frame the waiting for game screen is triggering this command is file ready request. So it's basically trying to it's asking Dolphin like, is there a file that I can play, right?
Can you scroll up a little bit?
Oh, oh. I fucking hate it. Sometimes debug mode doesn't want to compile, and I might have to. I'm just not gonna do it. Oh well. What do you want me to scroll up for?
Sorry, scroll up to the beginning of this function.
Yeah.
Okay, this is still the DMA, right? Okay.
Yeah. So this is DMA, right? And what's happening is that the game in waiting for game, every frame is saying, is there a file ready?
Over and over.
What's that?
It just triggers that over and over every frame.
Yeah. And that triggers, that calls this prepare is file ready function. The mRead queue is basically the response we're going to send back to the game.
Okay.
And it's just I think it's a dequeue. Oh, it's a vector. Okay. So it's a vector of bytes.
Okay.
And we call this is new replay, replay com is new replay. So replay com is the Slippi replay com.cpp file.
Okay.
And this is where like all that stuff with that input file you were asking about lives.
Okay.
So when is new replay is triggered, what happens is load file is called. So basically it like tries to load that file from disk again, so read file to disk, and then it's JSON. So we use this JSON library to parse the contents, and we like write stuff to our class variables.
I see. Okay.
And so we write the stuff that it's requesting, and now there's a replay or whatever, and we'll go through like kind of what would have happened in this case. So is new replay is called. We load the file. We call get replay path.
Wait,
What's up?
what does load file do?
Load file does what I just said. It loads this. It loads this
Oh, it loads
file.
the actual SLP file that's
No,
stored.
it loads the communication file.
Okay, which is this txt.
Which is this txt.
Okay.
It loads this communication file and loads all of the variables into the class memory, which is like that stuff is defined here, or com settings. It's in Slippi replay com.h.
Sorry, can you go back to text file real quick?
Sure.
So that's
this
so
is
you
JSON.
can pass more parameters.
Mm-hmm.
Or not parameters. You could pass more like keys and values here that get interpreted.
Yeah, this supports more stuff. Like this is normal mode, but we also support queue mode. And like I think here's an example of a queue version.
Okay, so this maps up 1-to-1 with that struct over on the left.
Yes.
So you can give a mode, a path, start frame, end frame, and all those other things that I'm not sure what they do yet, but
yeah, start frame, end frame, output overlay files is real time mode. Command ID, and then a queue of watch settings. So this is the queue. So this is a queue of this. That's what these are. And these are just different replays.
I see. So playback, I don't know.
Yeah, so what mode queue does is it goes through each one at a time. This is how the combo video works.
Yeah, I see. So it just loads multiple different files. And
yeah.
Then...
So it'll do this one first and then this one until there's nothing left in the queue.
Okay.
So yeah, so that's what load file does. It just loads this JSON file in particular.
Got it.
Because that's what this class is for. This Slippi replay com file is all about loading this file.
Mm-hmm.
So it loads that file. Then from there it gets the replay path, which it looks at these com settings that we were just looking at because those just got loaded in.
Yep.
And in our case the mode is normal, so this is ignored. So it just like returns the path, right?
Mm-hmm.
So it returns this.
Mm-hmm.
And then it checks to see if it's changed. So it looks at the previous replay that it was currently reading versus the one that just got loaded. And then it also, let's see. Yeah, I guess it makes sure that the replay path is actually like has some data. Has command ID change. This is like, probably don't need to get super deep into this, but this is used by the desktop app so that you can load the same replay twice in a row.
I see. Okay.
So it's just like a unique ID that, yeah, you just pass it, and if it changes, it's like, oh, they want a new file, right?
Yep.
And then this is queue stuff, so I'm just gonna ignore this. And then this is new replay thing is calculated by if the path is changed or the command is changed, or this one, which we'll ignore.
Yep.
And then if so, it's like, okay, yeah, there's a new replay, right?
Okay.
So then, where were we?
We're at load replay.
Yeah, I wanted to get back here. So that was the is new replay function, right? So it loads and then it figures out if there's a new replay. If there isn't a new replay, it's gonna call this next replay. This only does something in queue mode, I think. Yeah,
I see.
Yeah. And then it's gonna return to the game a 0. So mreadQ pushback 0 will just mean that like 0, I think, is the result code for is file ready.
What is mreadQ again? It's just it's an array of bytes.
Yeah. So hold on. So yeah, meta. That was my test for the Japanese characters fix. Anyway, So yeah, mreadQ is just what we're gonna send back to the game, because what the game does is it calls this write function basically, and
Mm.
then after it calls the write, it knows that like, okay, the game or Dolphin has gotten the data I requested, because it's pretty basically synchronous. So then it calls this DMA read function. So this is what tells it like, oh, write the result to this address. So then what we do is we do memory copy to emulator at the address that the game requested, and Q address is, you see, it's the
Oh, I
front of
see.
mreadQ. So we just send it the data that we prepared in mreadQ.
Yep.
And then it's in the game's memory, and then the game can look at it and read what we have prepared.
Mm.
So in this case, we're returning a 0, which means basically, oh, there's no replay ready, which is gonna keep it looping and make it keep asking, right?
Okay.
If there is a replay ready, so we do replay com load game, and this actually like uh, we call it get replay path again, which is like the current replay path, and then result we do Slippi game from file. This is actually from the Slippi library or whatever. If I let's see, oh yeah, right here. So Slippi lib external.
Yep.
So this is just the thing that actually like reads the SLP file,
Okay.
and like extracts inputs and stuff, which is what we're gonna end up sending back to the game. So Slippi game from file, and then the path that was requested, and then if there's a result, I guess, because I think if the replay path, for example, like I think right now, uh, we would enter this. Like because remember right now we have a file in here, it's just not real. It doesn't exist, right? So
Yeah.
the is new replay will probably actually be true. And then it's going to get into this. It's going to try to load it, but then it's not going to be able to load it because it just doesn't exist.
Yeah.
So we're going to end up doing the same thing, which is just say no, the file is not ready, right? But yeah, so
Can
this is
you go back one more time to where the mreq is defined?
where mreq is defined or written to.
Uh, both.
Okay, mreq is defined here. So this is in the exi device slippy.h file, and it's
Okay.
a vector. So we can just like write to it. And then this is where we're writing to it, for at least for this specific request, which is the is file ready request.
Okay. And 0 is just not ready, and 1 is
Exactly.
ready. Okay.
Yeah. Yeah. 1 is what is gonna tell the game like, okay, you can start the game, right?
Mm-hmm.
Or it's gonna tell it like, I guess get. It's gonna tell it like, let's move on, and you can get the game info, and then
Yeah.
start the game. So yeah, I guess I don't feel like I need to go into this super deeply. I don't think there's actually that much here anyway, other than it looks like most of this stuff is for the queue stuff.
Mm-hmm.
But basically, this just loads the replay. Okay, so now if we do have a real replay, it's gonna return a 1, and that's what's gonna tell the game like, okay, let's move on. Once the game moves on, it's gonna call prepare replay.
Sorry, one more question. If you're pushing back 1, doesn't that 0 still exist in there? Why
Uh,
do you need it to be a queue if it's just like whether it's playing a replay or not?
it's just that's like where the data is stored. But see how we clear it every time?
I see.
So like every time there's a request, we just clear the previous result of data. It's just easier than like, I mean, the other way to do it would be to have an array. And if we had an array, we'd have to define the size ahead of time.
Yeah. Okay. I
This
see.
this does this
Just for ease of use.
Yeah. So we just clear it every time there's a new request.
Got it.
Yeah. So it's only ever gonna have one thing in it, in this case anyway. Yeah. So then once it moves on, it's going to do this prepare replay thing, which is, I guess, 0x75. Oops. And that's going to call prepare game info. And all this stuff works very similar. I mean, it's very similar to prepare is file ready in that we're basically just going to populate the contents of mreadQ with what the game wants.
Yeah.
So yeah, so same thing. We clear mreadQ. We just check to see if we've actually loaded a game. I think let's see. I think that was loaded in the is game ready thing. This file is kind of long. Yeah, mcurrent game. So yeah, if there's no mcurrent game, just return. This should never happen. And then if mcurrent game are settings loaded, or if the settings aren't loaded, this is probably more for if you're mirroring or whatever. Like maybe the file got created, but the settings aren't in there yet because it just hasn't been written to. Then just like return 0, and 0 basically just means for this thing it means we don't have the data that you want. You should wait, right?
Okay.
And like this is gonna happen while mirroring as well. It's like the game is gonna be like, I want this frame, and then Dolphin can sometimes respond with, I don't have it yet, right? And then so what the game does is it just like waits for a frame and then asks again. I don't actually remember if it's a full frame that it waits for, but it waits for a certain amount of time and then asks again.
Can I see the settings struct or whatever it is?
For the game itself?
For Slippi game or whatever it is.
Okay, yeah. So here, this is all the game data. So this is game settings. So you got a stage.
Okay, got it.
Yeah, and then you have like this is the header data, UCF toggles, and then like a map of players, which I'll have like the character info, like this player setting, so it has the character ID. Got it.
Yeah. Okay, that's pretty easy to grasp.
Yeah. But so once the settings are loaded, it's gonna start. Okay, this is gonna be a successful result code, and then it's gonna call get settings, which I think just. Oh, what the fuck? I don't think that went to the right place. I think that calls this function, which just basically returns the settings thing we were just looking at. I don't remember what this is for, but anyway, this is probably not too important. There's some stuff for mirroring here. The important thing is like you'll see how like okay, we'll grab the random seed from the setting and we'll add it to mreadQ. Append word to buffer just like writes an entire word to this queue instead of like it's a U32, right? Instead of writing a byte. Because normally when we do this, we're writing a single byte every time. Yep. This is just a helper function to write. Yeah.
I see. Okay.
And then I forget what this does. I think this is some chic Zelda bullshit that I don't think we actually need anymore. But it's needed for legacy replay files. I think this is just like it's like overriding some of the header info so that the game will start with Sheik and Zelda correctly.
Got it.
And then this is where we write the game info header. And the game info header is like basically the entire. I don't know if it's a struct in the game or whatever. It might be a struct, but it's just like it's this set of data that's used to initiate a game. It's like everything. So it'll have like data about like is items on, or like are we in coin mode, like all that shit.
So it's like just a ridiculously large buffer of info.
Right. We write the whole thing. Yeah, you can see this is the size, I guess.
Okay.
So it's I guess it's 78 bytes long, which is 78 words long. Yeah. Why did I do it like this? Oh, whatever. This is really bizarre. Anyway, so yeah, so it's 78 words long, and then it'll write all the words one after another, and then it's gonna tell the game like, okay, how to initiate the people's UCF toggles, like if they have UCF on or not. It's gonna give it the name tags so that we can initiate that, and whether it's PAL, and I think this is for if PS should be preloaded or not, which is true always now, but for old replays wasn't. And then this is if Pokemon Stadium is frozen. So yeah, so basically we just tell the game everything it needs to know to start the game correctly.
Okay.
And then I think you can imagine what happens next. Then the game actually starts, and then it starts requesting actual frame data. So it's gonna start requesting like read frame or whatever.
Mm-hmm.
And then we prepare the frame data. And the frame data, there's some stuff about fast forwarding here, which we can get to, but I'll just kind of skip over that for now. The sort of the TLDR here is that like, okay, we return a result code. The request, yeah, and the result code, I think I have an actual enum or whatever that describes what they are. So wait is 0. That means like we don't have the data yet. Terminate is 2. Terminate basically means like end the current game, right? So that would be like, for example, in the case where if we have an end frame defined, it'll terminate the game so that it can start a new one. Because basically what happens is it terminates the game, it goes back to the waiting for game screen, and then it'll start the next one that way. So yeah, so it returns the result code. I think 1 is like good. We have the frame data. And then, we get the frame data for the frame index that's requested. You'll see here that there's a payload here. This is passed in by the game. So before, I think for the is file ready and for prepare replay, there's no input. But for read frame, there is, because the game has to tell us what frame it wants.
Mm-hmm.
So that's why like it looks at the memory pointer. Well, I guess it passes the address of the memory pointer at index 1 because
Where is this memory pointer first created, or what are you passing in? Oh, okay. So it's just a okay. I see.
yeah, so it's passing by the game. So the game initializes it so that like the first byte is the command byte, the next 4 bytes are the frame index.
Okay.
And then we use that to read in the frame index. And then we try to get that frame, and then we basically just like, pass in the random seed, and then for every player, we do prepare character frame data. What the hell? What is this? Oh, I see. This is follower. So this is for ice climbers. Yeah. Most of the time, this will do nothing for, except for ice climbers. So yeah, so it calls this, and then it just gets a bunch of shit for that person. This is pretty straightforward. It gets the joystick X, joystick Y, C stick, etc., and that's how the replay works.
Mm-hmm.
So yeah, I think.
What function is that called from again? This is what part of which case switch?
Read frame.
Read frame. Okay.
Yeah.
So can you scroll up a little bit again?
Mm-hmm.
The top of this function. This is the right?
DMA right. Yeah. Everything's always like DMA write is always what the game is requesting, and then DMA read is after the game has requested something. This is how the game actually reads it out.
Wait, sorry, say that again.
So remember, this is DMA write, and this is telling us like to get our mRead queue ready.
Yeah.
and then afterwards the game is like, okay, after I've asked for a write, I know that Dolphin will have the read queue ready, so I'm gonna
Mm-hmm.
ask to read it. So this is where it
Okay, and
asks to
this
read it.
reads from
And,
Dolphin to the game.
correct, yeah.
Okay, I see.
Because this one writes from the game to Dolphin, and then this
Mm-hmm.
one asks Dolphin to write back to the game.
And then the gecko codes handle the rest for like
Yeah, the gecko
handling.
code will like put stuff in the right memory addresses and all that stuff.
Got it. So
Yeah.
if that's the case, you said earlier about the replay stuff, like why you prefer the save states over not doing it is because like you don't have enough information to reset up the situation perfectly, right?
Mm-hmm.
But wouldn't that just be mean like in the worst case, like it desyncs for a little bit and then resyncs?
Mm, potentially, but it might desync for like like some desyncs are not recoverable. I mean, I guess we could make all desyncs recoverable, but for example, I think one that we absolutely can't deal with is stage position right now, like Pokemon Stadium.
Uh-huh.
Um, but I mean, I think that's a good point. Like, it might be possible to do that, just like load something and then we know it'll desync. Uh, but yeah,
Yeah, I mean, I was mainly thinking about like the save state diff approach, which I mean sounds like it would work, but
Meta is in my chat, by the way. Uh,
oh,
so
is he?
yeah, so he could always provide insight on the save state diff stuff.
Okay.
But
Because as far as I know, I feel like maybe it's different now, but I feel like the save state stuff isn't that robust and can cause crashes sometimes. But I wouldn't really know any details.
yeah, I don't know.
I'll definitely
I mean, we'd have to
ask that
test
later.
that. Anyway, so let's just Oh wait, I forgot I can't launch this in debug mode. I was just gonna play through it just so we could like see everything, but
Yeah, I mean, I think I can probably do it my own time.
yeah. Um, I'm trying to think if there's anything else. I think that's like the core of it, really.
Okay.
Uh, I mean, there's all the stuff in Slippy game that we kind of just like ignored. This reading the actual SLP file into these structs, but I mean, it's
Yeah.
pretty.
Yeah, I mean, I can
It's
kind
not
of.
super
I mean, the
relevant.
stuff I'm going to be working on, I can just assume that it works.
Yeah. Yeah. Uh, yeah, I think that's pretty much it. So there's the EXI file, which is where all the communication stuff is happening from
Mm-hmm.
like the game to Dolphin. There's the replay Slippy replay com files, which is for reading this thing,
Yeah.
and then
This is,
there's the Slippy game files, which is for reading the actual SLP files.
this is very neat in that it seems very detached from like every other aspect of Dolphin.
Yeah, yeah, that's kind of the nice thing about doing this
Like it's
in.
literally just like that one gecko code that you check
Yeah, it's
like
not
that one.
that's why it's nice to do it like in EXI instead of like trying to read and write to memory like directly in like awkward spots. And
Mm-hmm.
since we do it with EXI, it also means that like technically all this stuff could work on console, which it does with Nintendo. But
Yeah,
Nintendo, we could even hack around it, so we didn't have to do that. But since it's all EXI, we could have a hardware version too.
I see.
Yeah, Meta says save states necessary because replay files do not encode everything necessary to preserve about game engine state. Yeah, I've discussed that with David before. Meta, I think what he was suggesting is that like we still try to restore it as best as we can, and like some stuff we can't restore, so it won't get restored, and it'll just desync until it finally resyncs, which actually would work to some extent, uh, but it would not work fully. I don't think.
Yeah, I can think of like stadium stuff that probably wouldn't work.
Yeah, it would also be kind of jarring to just like you go somewhere and it's like just desynced for like 10 seconds.
Yeah.
But okay, cool. Any other questions?
No, that's pretty much all the Slippy stuff, and then I can talk to Meta about.
Yeah, you can talk to Meta about the diff stuff. Uh, I'm not super knowledgeable in that.
Cool. Yeah, thanks for the rundown.
Yeah, no problem.
Yep, see ya.
See ya.